Switching over to number 9, A through C. Go ahead and pause this video so you could get to that question and then unpause it. So on 9A, it says, write the letters representing the parabolas that have a minimum value. In order for a parabola to have a minimum value, it has to be opening up. So if it's opening up, your A value has to be positive. So when you see these words minimum value, you know that you need a positive A value. So this is a -1 A value. This is an A value of +1. This is a negative A value, positive A value, positive A value. So out of the 3 positive A values, how would you list them in order from narrowest to widest? Remember, if you have a 3 out here, then that means it got vertically stretched by 3. It's pretty narrow. But if you have a regular A value of 1, then you have a regular U-shaped curve. It's not that narrow. But if you have a A value of 1/2, technically that's a vertical compression. So it's definitely wider. Okay? So from narrowest to widest, the narrowest one is B, because that's vertically stretched by 3. And then the next one, it's not so narrow, not so wide. That's a regular A value of 1. That would be C. This one has an A value of 1. And the last one would be D, the widest one. That's opening up, that is, because the A value is 1/2. Now, if you look at 9B, it says which parabola is the widest? The widest parabola, if you think about a wide parabola, the widest parabola will be the one that has the A value closest to 0. The further it is away from 0, the more narrow it gets. The widest will be the one that's closest to 0. So the one that's closest to 0 would be E, which is -1/9. That's the widest one. And it's opening down because it's a -1/9, which means it has a maximum value. On 15A through C, we're going to be having the same problem over and over and over again. Okay, so this, you're going to see it appear on your multiple choice test 3 times. It's going to look exactly the same over and over and over 3 times. It's going to all start, Brenda collected this data from an experiment. The next question, Brenda collected this data from the experiment. It's going to look like if it's repeating 3 times. So this one's very important because we have this one type of question that repeats 3 times, and that's 3 out of 20 is 15% of your grade. So let's focus in on this one. It actually asks different things. On 15A, it's asking for the residual. And I hope we remember what residual is. Residual is actual minus predicted. So how are we going to get the actual data? You go to your data table, and it says you want your actual data at t equals 9, and you want to subtract your predicted data when the 9 hours happen according to your line that best fits. So let's start with the actual. So you go to the hours and you go to 9, and you're going to be looking at this coordinate right here. The actual data at 9 hours, this plant grew 5.6 inches, or was 5.6 inches tall. The top is the hours of sunlight, the T, and the bottom is height in inches. So maybe it's about talking about a plant. But anyways, at 9 hours, this thing grew 5.6 inches. So the actual data at 9 hours is 5.6. And we need to subtract the predicted value. And the predicted value, that's a little bit more difficult to find, because how do we predict values? We use the line that best fits. So what we need to do is, since we're focusing in on this coordinate at 9 hours, the actual data was 5.6, we need the predicted data at 9 hours, and the predicted data would simply be to plug in 9 right here where your T is at and work it out. See, I rewrote the equation of the line that best fits, and I'm going to plug in the number 9 right in here. So there's 9 right in there. And if we work this out, you could use a calculator on the test if you want. 0.6 times 9 is 5.4, and you have plus 0.44. So that's 5.4 plus 0.44. That is 5.84. That's right. So that is the predicted value, okay? This is the predicted value. So I'm going to actually write this over here into the predicted spot, which is 5.84. So we really have 5.6 take away 5.84. You could use a calculator. I'm going to think of money. If I had $5.60 and I owed somebody $5.84, I would still owe them 24 cents. But bottom line is your residual is negative 0.24. That's the answer for 15A. If we move on to 15B, 15B, it says for the line that best fits, and it's the same exact best fit line, and we want to find the prediction of when t equals 30. So it's kind of like if you look right here, it's 3 hours, it was 2.6 inches tall, 5 hours, 3.4 inches tall, 13 hours, 8.4 inches tall. The question is, how tall would it be at 30 hours? So in order to do that, to make predictions, we use the line that best fits. And once again, the line that best fits is right here. It's the same exact one. All we're going to do is plug in the 30 hours into the t spot because that's time. So let me write it out. My line that best fits, and I left the spot for the t, which is time, and I'm going to plug in the t they want me to plug in, which is 30. If I plug in 30, that'll give me the prediction after 30 hours. So let me work this out. 0.6 times 30, that's actually 18, no more decimal. And then plus 0.44, that's simply 18.44. So what's your prediction? That after 30 hours, it's going to be 18.44 inches tall. That's your answer for part B. Let's move on to part C. On part C, it's a little different because it says for the line that best fits against the same line that best fits, when the height is 21.5 inches, or actually, let's read the question again. When is the height approximately 21.5 inches? So it doesn't say after 30 hours. It doesn't say after 50 hours. As a matter of fact, they don't even tell you the hours. What they're giving you is the 21.5 inches. That's the height. So where does the height belong? It belongs right here where h is at. So in this case, it's different than the other ones. I'm actually going to plug in 21.5 onto the h spot right there because that's the height. I don't know the time. I don't know t. I don't know how many hours. So I'm going to write this equation. And I need to solve the equation. And of course, you could use a calculator. Subtract 0.44. Subtract 0.44. 1.06 equals 0.6t. And of course, to get the t by itself, we're going to have to divide by 0.6 and divide this side by 0.6. And with the calculator, you should get t equals, is 35.1 equals t equals 35.1. So, of course, it takes 35 hours, a little bit more than 35 hours, in order for that plant to grow to the height of 21.5 inches.